Hello and welcome to the fresh episode of Defense Fallout. Today we are going to discuss a very interesting topic, that is what penalties is a military aircraft has to face when they actually operate at a high altitude. Now the Indian bases, the Indian air bases, which are mostly around 700 to 900 feet. So the air bases start from Leh, which is in Ladakh, and then it goes to as far as Chabua, which is in Arunachal Pradesh. No, mostly all these bases are from 700 to 900 feet except Leh, which is at 10,000 feet from the sea level. Now, on the other hand, the Chinese bases, they're mostly at around 11,000 to 15,000 feet from sea level, except two air bases, that is Hotan and Kashgar. These are in the Tibet Autonomous Region. Now, only these bases are at less than 5,000 feet from the sea level. Now let's discuss what penalties they have to face now in different phases of flight. Now there are three phases, as you know, that is takeoff, then you cruise or you get into battle, and in the final phases you recover the aircraft or you land back. Now while you take off, whether it be a transport aircraft or a fighter aircraft, you should because the base is at such a high altitude, there is a reduction in thrust output from the engine due to obviously lower available air and oxygen. Now this results in higher takeoff roll, that means from the point you set the thrust to the point you roll, that means you pitch up, till then the amount of runway you consume is on the higher side. Now obviously because there is not enough air, you generally try to gain maximum performance from the engine, therefore you'll have a higher fuel burn. Now because of which the RPM of the engine is also on the higher side, that will result in more wear and tear on the engine. And also we are aware of the Chinese and Russian engines, that they aren't that great when compared to the Western engines. Now the average service life of a Russian engine or the Chinese engine is around 2000 to 3000 hours. Now whereas on the Western engines you get as high as 8000 hours too. Now obviously because of these conditions you don't get good performance from the engine, and there is more wear and tear. And another option is you can't use flex or derated temperatures. No, it doesn't mean that whenever a aircraft goes on to take off, it generally uses maximum power from the engine. They use something known as flex temperatures or derated temperatures. That means that any engine which is involved in this takeoff procedure, they use a they feed into the system which is a temperature which is lower than the actual environmental temperature for takeoff calculations. So this means that the aircraft's performance data, especially for takeoff distances and thrust requirements, now for these you get minimum takeoff distance and maximum thrust at the same time. You generally put on temperature which is higher than your surrounding, so that the engine generally produces enough thrust that you can get maximum performance. That is what the flex temperature means. Now you can't use this particular feature at higher altitudes because you need maximum thrust to just take off. Now you also need higher flap settings. Flap is nothing but a high lift device, which is an aerodynamic device which is fitted onto your wings. Whenever you extend it, the flap, the wing which is there, let it be a conventional wing design or the delta wing design, the surface area of the wing increases, which results in more lift. Lift is a force which will help the aircraft to get airborne. Now this flap setting is should be put on the higher side because obviously you have less amount of air, so you obviously want more wing area so that you get more lift. Now because of which the drag, which is another force which actually puts onto the aircraft, now this drag is also increased, and because of this reason there is higher fuel burn too. Now when you get into cruise or battle, now because of the lower air density which you get at such a high altitude, you can't perform these high G maneuvers because the engine performance is highly reduced. Because whenever you get into dogfights or any battles, there's a lot of thing about energy. Whether you want to get into offensive position or you want to get into a defensive position, You do instantaneous and sustained turns, which are two different. Instantaneous turn means you suddenly have a higher rate of turn, and you get in turn of you that is generally done to evade any missile. Now these turns require a lot of energy which is wasted, and then to regain this energy you need a lot of engine power. Now you can't do these in high environment conditions because you lose the energy so quickly, and you can't regain it when you want. And then the lower combat effectiveness of the aircraft because of the reduced payload, because you can't take go with maximum weight or maximum payload. What you do is you actually load less amount of weapons and fuel, and you try to employ more aircrafts to do the same job, whereas the opponent does it in less number of aircrafts and become more effective. Now for this you actually, because you are operating in such condition that you have a lower combat effectiveness because you are not carrying enough payload. And then you have higher stall speeds. Stall is nothing but the moment where the airspeed is not okay. Now for this I have to explain you what airspeed is and what ground speed is. Now the airspeed is that suppose I am heading, suppose there are winds from north to south, which is around 15 knots, and I am going from south to north at suppose let say 500 knots or 600 knots. Now at this speed the air under my wing is 600 knots of my own speed and 15 knots of the headwind which I am getting. So this combines the when you combine both of this you get 615 knots, that is your air speed. Now what is ground speed is the speed of your aircraft with respect to ground, that is 600 knots, that is the ground speed. So ground speed and air speed are never equal. Mostly they are not equal because there is some wind which is always blowing. Now because there is not enough air which is blowing, that's the reason the air speed is generally on the lower side. That's the reason the stall speeds go higher. So the stall is nothing but the aircraft, when there is no enough lift generated, the aircraft starts to fall down. That is what you call stall, and the speed at which the aircraft stalls is called a stall speed. And generally for commercial aircraft it is around 120 knots or something, and military aircraft it can be higher. But when you operate at such a scenario, that is you operate in high mountain region, the stall speeds also increase, and that is not increased by a small margin, it is significantly increased. Now obviously because you have mountains and most of the communications are at line of sight, because as you are aware that the VHF, which is very high frequency, is something which we use for communication, for the RTA, the radio transmissions. Now because of the mountains, this line of sight is obviously being interrupted by these mountains. That's the reason the communication between the pilot and the ground station is disrupted. Now when it comes to landing, or when you recover the aircraft, the problem is that you need higher landing speeds, because the stall speed is very high. You can't land at stall speeds. That's the reason you need to be higher than that, because of which the speed at which you land is higher than the speed which you usually land at airbase which is close to sea level. Now because of this, because you are coming at a higher landing speed, the braking which becomes more least effective. The braking is not that effective. Why it is not effective? Because when you land, it is not only that the brakes which are connected to the wheels which help you to stop the aircraft. It is also parachutes and ground spoilers, which parachutes is what you have seen in lot of military videos. You have seen it for Mirages, MiG-29s, Su-30s and MiG-21s. Now ground spoilers are also a mechanical device which extends and which creates extra aerodynamic drag that will slow down the aircraft. Now there is no enough air, that's the reason the landing distance also increases, and at the same time the braking effectiveness also decreases. That's the reason you need more long runways to stop. Now when it comes to unmanned aircrafts and transport aircrafts, Now, when it comes to unmanned aircraft like the UAVs or drones, which we do it for ISR, which we use it for ISR. ISR is nothing but intelligence, surveillance, and reconnaissance. Now, for these missions, that is where intelligence is nothing but you, from your intelligences, you get any input about so and so locations. Then reconnaissance is you gather, you send your reconnaissance aircraft and you collect information. And intelligence, surveillance, and reconnaissance. Surveillance is nothing but you just keep an eye on the enemy. So for these missions, you generally use your drones and UAVs. Fighter jets, we used to use it like long back. Now they aren't effective because they come up on the radar soon when compared to these drones. Now, because mostly these UAVs and drones again depend on line of sight communication, because there is always man in the loop. That means a ground controller should continuously communicate with the drone and direct it towards the target. That's the reason, because these communications are in line of sight, you can't operate these UAVs so effectively in mountain regions or high altitude regions. Now also these effective operational range of these drones do come down, because at the end of the day even they use an engine which needs air. Now when the air is obviously not enough, obviously the effective operational range obviously reduces. One which has an endurance of 24 hours or 30 hours will automatically come down to half, might be 12 hours or 15 hours of endurance, and that too with limited payload. So you need to employ more number of drones, or you need to continuously replace those drones with the new ones, so that the other drones can refuel and rearm and then go again. Now they can't fly low too, because drones they are picked up by radars. For your surprise, even a flock of birds can be detected by radars. Now drone is nothing, like drone is much bigger than these birds. Now because drones are designed to fly at a lower altitude so that they can complete the mission and don't come up on the radar. Now because of mountains you can't fly close to the mountains, you have to because of these issue with the line of sight communications, you have to go a bit higher, because of which it easily comes up on the radar. Now, and also all round stealth UAVs which we have in the Neuron, which is a Dassault drone, and also you have the B2 bomber. These are something which have all round stealth capabilities. Now only these kind of what we call these UAVs or the unmanned vehicles, aerial vehicles, so only these can actually withstand such scenarios, because they have that kind of stealth capabilities. And when it comes to these transport aircraft, same, when any strategic airlifters like the C-17 or the IL-78, which can carry some 30-40 tons of payload, suddenly when you have when you land at these advanced landing grounds in Leh or Arunachal Pradesh or in the Tibet regions, because of the altitude of those ALGs, you have to carry less amount of fuel and payload with you. So obviously even the strategic airlifters will not be able to operate in the scenario which they have to. Now radars and surface to air guided weapons are also very important, because these are the combat enablers of the Air Force. That means without these you can't actually get into a proper, you can't even fight against the enemy. Now the radars is obviously used for surveillance, and the surface to air guided weapons are to engage the enemy. Now you can't place them at the base of the mountain, because obviously all your radar waves and the missile is only pointed towards the mountain and not beyond it. Now that's the reason you have to place it on top of the mountain, because of which the enemy can easily target those radars using anti-radiation missiles. Now the effectiveness also of these things also reduce. Now due to the environmental conditions, the performance will obviously come down, because none of the radars are designed to operate at -30, -40 degrees Celsius. They are designed to operate at an ideal environmental condition. Now when you bring it to such an extreme conditions, even an S-400 can't give you a 600 kilometer range of surveillance. So even their missiles can't go up to 400 kilometers because of the given operational ranges. And obviously, as I told you, the anti-radiation missiles can easily target them. So it is not ideal to place it on top of the mountain, but even you don't have any other option too, because when you have to perform surveillance against such an enemy, you have to put it somewhere that at least you have one eye on it. And that's it for today. Thank you. Jai Hind, Vande Mataram.